Hi, this is Pat Sauer, and this is year 3 of looking at urban plants, or plants in different urban spaces. Joining me is Tom
Rosburg over here from Drake University.
and
Ken Tritech, City of Des Moines.
so we're here at Ewing Park in the city of Des Moines, and we're going to be looking at different aspects of the park and thinking about green spaces first. You know, what we typically do training associated with stormwater management, but looking at urban green spaces in terms of how can we capture and infiltrate and have healthy environments that provide all those ecosystem benefits, not just looking at stormwater management, but the plant communities, the wildlife communities that exist here, and a whole host of other benefits, including recreation and human health and such. So we're gonna get started on this tour.
So Ewing Park was deeded to the city by the Coffin family roughly 50 years ago. And the city has done various maintenance things since then. I know back when it first started, they had mowed the entire area with tractors with brush hogs on the back. But that has not happened in a long time. And you can see behind me what it now looks like without any management done to it recently. And what we're doing is we're coming in with a forestry mower and cleaning up some of the honeysuckle, and just so we can walk in there and treat the invasives. And then we will also use a diamond deck to mow once the forestry mower has opened it up. And then we try and use prescribed fire on the whole park, but a lot of the times until we get a little bit more of the canopy opened up, the fire doesn't go very far into the woodland. And we try and burn it once every 2 to 3 years, given the right conditions, and it needs to really be dry for that fire to carry through the woodland.
And Ken, can you talk a little bit about the area that has been managed most recently?
Yeah, we mowed it, and then we came in and removed, well, I'd say 50% of the trees that we would like to remove. We're trying not to do that too much to keep the wind from blowing over the trees that have gotten used to having no wind go through there. And then we recently burned this spring, and we will try and burn it again 2 years from now. And it is markedly different than the other area.
And what is the benefit of opening up the canopy and removing undesirable tree species in the understory? What's the benefit of that?
The benefit of that is we can get more growth on the ground, and that creates more ground cover. A lot of honeysuckle, it's bare underneath it, and we'd like to see plants growing so that you can have more areas for wildlife, easier to walk through, manage, and treat everything.
And what sort of, is there any, you had talked a little bit about equipment, but what sort of equipment is sort of roughly what size type equipment do you use for maintenance?
The forestry mower is a self-contained unit. It's roughly the size of a large bobcat with metal tracks on it. And we have a 770 bobcat that we use for the diamond deck.
And how many staff do you have that are used to maintain this 300 plus park area?
Well, our staff, the staff that the NRC crew manages the forests and the prairies, and it is 2, and we just have an additional 3rd full-time person that came on 2 weeks ago, and we have 3 7-monthers that help us.
Okay. And tell me about the management. Is there a management plan for the park?
Yes, in the woodlands, we're trying to get in there and burn them and then clean up the down trees so that we don't have to put every single tree out every time we burn. And then once we do that, we will try and get it mowed and try and keep it mowed, and we will also treat the honeysuckle and other invasives like Oriental bittersweet is all throughout this park too. So we're treating those.
And how do you prioritize the areas in the park? Is there a plan? Is the park divided up into regions or areas?
We have kind of divided it into the areas we've started working on the east side of the park and areas we haven't. So if we have a chance, we'll get to where we've started to work on that area and get that completed before we'll move on, just to try and finish an area first.
In 2011, 2012, Des Moines Parks and Recreation hired me to conduct a natural resource inventory of the parklands. It kind of had two major goals. The most important one was to do surveys in parks like Ewing here that have a strongly sort of natural landscape remnant or aspect to them. So roughly 3,000 acres of parkland was surveyed, and the goal was to map what the extant ecosystems are and plant communities are right now, so what exists here now. And then also I tried to give the parks an idea of what used to be here by looking at soils, looking at old aerial photos, try to interpret those, and also actually GLO maps. Those are the Government Land Office maps, which again show what the land surveyors saw here back in 1850s or so. But to give them an idea of what kinds of ecosystems and plant communities occupied this landscape prior to what we see now. That gives them at least some idea maybe of what direction they might want to go when they think about restoration. So a lot of what happens in Ewing Park, I think, is a good example, of course, is that what we probably had much of our landscape through the Des Moines area because of the way that fire would have occurred on this broken landscape, rough landscape. It wouldn't have been a complete burn. It would have been broken up again by the topography. Fire would have been reduced somewhat to lower intensities and frequencies, which of course promotes the growth of trees, but probably not near to the extent that we see here. It's my opinion that probably most of the landscape here was a combination of prairies, savannas, and woodlands. And I use the term woodland in a different way than maybe is conventionally used. There's really, a good way to think about it is there's really four basic ecosystem types that depend upon the environment, depend upon the amount of fire that's occurred in the past. So you have prairie, where virtually there's no trees, less than 10% canopy covered by trees. But then as fire is diminished because of whatever reasons and factors in the environment to not occur quite as often, becomes a little bit more patchy. A few more trees are able to survive those fires. Now you get to a range where the canopy cover is between 10 and 35%. That's a savanna. And you can just keep going, of course, as you get into more parts of the landscape where fire was reduced, the frequency was even less, and therefore then the frequency of trees goes up. We get to the range of 35 to 65% canopy cover. That's a woodland. And then in the most fire-resistant parts of the landscape, the parts of the landscape, again, that would provide the most protection to trees, there's where we have the forests. And the forests are 65% canopy cover or more. And again, I think that probably most of this landscape was a woodland, savanna, prairie mosaic. And because, of course, the loss of fire as an environmental factor happened a long time ago and has been a factor for a long, long time, it's those savannas and woodlands that had a tree component already present that it's easy for them then to increase that tree component because there's a source of seeds. And especially a woodland. A woodland can fairly quickly succeed to a forest. It doesn't take too long for additional trees to come in and fill in those gaps, and before you know it, again, you've got canopy coverage that's 65% or more. So again, what the park, what Des Moines Parks and Rec, decides to do might be somewhat based again on sort of what might have been here at least, but you also have to factor in what's reasonable too. In some cases, although there may be signs that this area was a savanna with, again, maybe 20% canopy covers of trees and a lot more openness in the herb layer, if it's now a forest that's got 80% canopy cover and a herbaceous layer that has no prairie species whatsoever, it kind of doesn't make sense to spend all that time and effort trying to go back to something that's going to be really hard to do. You still got an environment that supports biodiversity, just a different type. So then the other part of what I did for the Park Service, the Des Moines parks, I should say, was more focused on the smaller parks, parks that have more open green space and are more playgrounds and recreational areas. In those areas, I just did surveys of the trees. I think in these larger areas, though, again, the goal was to find what kinds of plant species are here. I did a rough floristic inventory of each one of those plant communities and ecosystems that I mapped, trying to focus again on a common and abundant species, and then also trying to know whenever I found really bad populations of invasive species, or when I found populations of unique species, anything that would be an imperiled species. I found 7 different populations of imperiled plant species within the parks, and lots of course, highly conservative plant species. So, and that's the kind of information I think that's probably going to be most useful, and hopefully helps folks like Ken, think about, what's the best management strategy for them to go forward. That was the whole point, of course, of this survey, was to provide them with a baseline inventory of what they've got. You really can't really do a good job, or at least, I guess profess that you're doing a good job of managing some land unless you really know what you've got. Unless you know what's there, then it's going to be kind of hard to know for sure what's going to be the best direction to go.
Ken, could you tell us, how do you decide which trees to remove in a woodland like this?
Well, we first look at overstory trees and try and release those, like an oak, a hickory, a walnut, a lot of times, sometimes a basswood. And what we'll do is we'll just pick the trees around it and remove those first, and then we're trying not to take out too many trees to give that tree time to get used to the more wind so it doesn't blow over. And if some of the trees that we want to take out are too big, we will girdle them and leave them for the wildlife to use. And so a lot of the other overstory tree that we leave a lot is hackberry. There seems to be a lot of those.
We walked over here to this area that Ken pointed out earlier hasn't had any removal of the understory or thinning happening yet. So we're going to take a look and see what's growing over here. And of course, the first thing we notice right away is the invasive species, like I'm standing in front of right here. This is Tatarian honeysuckle, on that top 10 list of some of the most invasive species. There's 2 species, of course, that are really hard on us, Tatarian and the Amur honeysuckle. This one is Tatarian because we can see the shape of the leaf here. Fits it better. There's another invasive back here, a little bit further back. This one is the common privet, which again is another example of a species that's introduced for landscaping purposes and has escaped into our natural areas. Get a close-up of the leaves on that one. So those are the 2 most invasive problematic species I'm seeing right here along this edge. Again, you can kind of look through the background here, and any place you see those white flowers, that's some honeysuckle. But what else is here? Well, there's some good things like the false Solomon seal you see right here, beginning to form some flowers here. False Solomon seal. This one down here, right next to it, is common black snakeroot. Again, starting to form some flowers. There's some sedges in through here. I noticed one right here. Without pulling this up and looking at it real close, my guess is this is Carex aggregata, the cluster sedge. And here's another of the non-natives that is a problem species, a little bit smaller version of one here. This is multiflora rose. And we can see some native shrubs like buckbrush right here. Symphoriocarpus. You see there Symphoriocarpus orbiculatus or Symphoriocarpus occidentalis. Depends on whether it has red or white fruits at the end of the summer. Then I noticed that there's this nice young specimen of oak right here, a bur oak. A tree this size, which is about 10 centimeters dBH or so, again, is sort of an uncommon tree size to see in any of our forests nowadays, because the size distribution that I see most often in forests and woodlands is we've got a number of the grandparent trees, I like to call them, the big oaks, and there's a couple examples here, of course, that we can look at later. And then there's always usually a lot of maybe small little seedlings. I noticed some seedlings over there, about that size or so. But the age classes that are in between the small and the grandparent size, we don't see too many of those. Here's a good example of one that we do have, this size range here. And this is the size that, we need to see more of these trees in our woodlands and forests to replace the older trees when they die of natural causes, or wind blowing them down or wherever it might be. Because if we don't have these sizes of oaks coming along to fill in, then the forest gets replaced by other trees that have younger trees in this size range, and are probably going to be more like basswoods or maples, or more the tree species that are more tolerant of shade. So that's one of the challenges I think that any land resource manager has nowadays, like Ken, is if you want to try to maintain our oak woodlands and forests, somehow we've got to help encourage the regeneration of oaks from the shrub size that, again, we have seedling and shrub size plants. We need to get more of them into the teenager and young adult size that we see here. And now we've walked up the hill slope a little bit here into this area that Ken described as, again, having a lot of work done, removing some of the brushiness, removing the invasive species here, and clearing out the understory somewhat. We can see that it's clearly more open, and that helps, again, to promote a more vigorous herb layer. And because of the extra light, we should maybe see again, a little bit more representative species of plants in the herb layer here that like a woodland environment. And a couple come to mind right away. As we walked up here, I noticed Solomon seal right here. Solomon seal, which is similar looking to false Solomon seal, but it has its flowers coming off the underside of the plant in the leaf axils. Each of these leaves has a little flower that's dangling down here, or at least the start of a flower. This is a plant, I believe, that really is more of a woodland species. I quite often see it in even more sunny environments than this. So I think it's a good example of a plant that, if it had its choice, it would be in a savanna or an open woodland. But because those habitats are all closed in now for the most part on our landscapes, and now are sort of technically a forest, we see it in those environments. And here's an important point. Just because we see it in those forest environments now, that doesn't mean that it prefers that environment. It's there because that's what it's got. It's still a hangover, if you might say, a leftover from a time when, again, the environment might have been more open, and its ancestors, again, were living in a more of a woodland or savanna. But a lot of these plants, of course, will hang on in a more shady environment. They may not prosper quite as much, but we think of them then as forest species because that's where we see them. Well, we see them there because that's the only place that they have. Another good example of that many of you probably are familiar with are the trout lilies. So we can see some leaves down here. They're finishing up. This is the spring ephemeral that was in bloom probably a couple weeks ago, if it was in fact in bloom. Not all plants are going to bloom. That's another good example, I think, of a species that, again, on the native landscape was probably did its best, had its highest population success in more of an open woodland. We also have some anise root right here, just some other things to point out. Anise root, Osmorrhiza longistylus. It has, like its name suggests, its styles on these flowers are extra long compared to its congener, Osmorrhiza claytonii, Sweet Cicely. So Sweet Cicely and anise root look very similar. You can tell them apart really easy right now because you got those flowers with those long styles right there. Another one that we see, aptly named woodland phlox, is this one growing right here amongst this moonseed. Here we go. Woodland phlox, Phlox divaricata. 5 petals, fused corollas, very long tube. Clearly a plant that's pollinated by an insect with a proboscis that's a little bit longer, can reach down that long tube. And up here we also see some more of the black snakeroot, common black snakeroot that we just pointed out a little bit ago. I found some plants here that I think really have an important role in what Ken and Des Moines Parks want to try to accomplish here. Here's a sedge. This is Carex grisea, or eastern woodland sedge. You can pan on that close. The plant is right down here below me, right down here. And then another graminoid is this one right here, woodland fescue. It's just beginning to form a flower head there. There's another clump of it just a little ways away. But if it might be possible for Pat to kind of pan just around this area right here, we see a lot of younger grass-like plants coming up. That's going to be a really important part of, again, transitioning this to a woodland, because the grasses provide a very important, and sedges, because they're like a grass, provide a very important ecosystem function in how they promote the frequency of fire. Grasses have a fine texture to them, and so when they senesce and die back, the fuel that they provide is a fine fuel, more of a fine fuel, as opposed to some of the more coarse types of fuels that come from the forbs. It's that fine fuel that really helps to promote a fire then and carry the fire through. What we want to see here, of course, is what we call a surface fire. Make sure that you understand we're not talking about a canopy fire or anything like that. We don't have those here. But a surface fire, which of course burns the herb layer. Any of the woody vegetation that's, like this little honeysuckle right here that's sprouted back, those will be top killed by a fire. Any of the small woody stems, the shrubs and saplings will be affected by the heat of the fire and top killed. Larger trees, aren't going to be affected. Basically, there's not going to be enough heat that will penetrate their bark, and they're going to survive the fire just fine. At some point, trees stems get large enough to tolerate that heat. But saplings, so stems that could be up to maybe an inch or so in diameter, maybe 2 inches in diameter. I did a study a while back looking at fire effects in a woodland forest system, and we found that a surface fire, low intensity surface fire, did have an effect in increasing the mortality of saplings. So again, trees that are usually a couple meters high at least. These could be young trees, of course, of species that are growing there, 2 meters or so tall, maybe up to a couple inches in diameter. The heat can kill those, and again cause them to at least top kill them, kill off the top. It won't kill the roots, but at least reduce the size of those woody plants to something that will grow back from the root system that'll be a lot smaller. That causes, again, more light to come into the environment. It helps to increase the growth of herbaceous layer, helps to increase the growth of the sedges and graminoids. And what happens then, in a sense, if fire happens enough and you keep that cycle of keeping that woody growth down and minimized at least, is that it's a positive feedback. the more fire you have, the more fine fuels you develop. The more fine fuels you develop, the more it's easy to carry a fire. The hotter that fire gets, the more damage it does to woody plants. And again, it can be a positive feedback mechanism that, you know, takes you in the direction, then at least, of making the herb layer and the ecosystem more open.
Question for you, Tom, is the herbaceous layer that is here, is this all native seed bed, or would this have been seeded?
This is all native plant material that was in populations that were able to live under a more shaded environment, however much, you know, shading and understory density there was here, which of course was quite a bit more than we're seeing now. So these are examples of plants that were able to tolerate, for the most part, you know, tolerate that shading. Now they again probably weren't this extensive back when there was a thicker layer of invasive shrubs through here, but they were still here, and probably in lesser numbers, maybe in a more depauperate form. And what we're seeing is sort of explosion, I suppose you might say, at least a better growth, better productivity because of the removal of those invasive shrubs. But I think for the most part, yeah, these were all here. I don't think the parks have seeded anything. Ken's shaking his head no. So they haven't done any seeding here. Could that be done? Yes, I think that could be a strategy at some point in time to try to, again, convert this herbaceous layer into something that, again, would be more representative of perhaps what it should have been or was like when there was more light here. Clearly, you know, there could be some populations that have been lost here because of the density of that layer of invasive shrubs.
So this is an example of a girdled tree. We used a chainsaw to just cut in far enough through the cambium layer so that to prevent the flow of sap going up and down the tree, and that will kill it. And we're trying to leave some of the larger trees for woodpeckers and there's animals that will use the dead trees. So we're not trying to remove all the dead trees.
Why do you make two cuts?
Two cuts, so if you make one cut, it's going to heal over. Two cuts will keep it from healing over.
How long does it take to kill off the tree?
It's dead when you do it. It just doesn't know it yet. So, yeah, it'll try and leaf out, but it's not going to grow.
And then the tree, do you come back through and take it down, or are you just going to let it fall? Or
we'll just leave it for wildlife, and then sometimes we do have to monitor it. Sometimes there will be some that start to fall over and we'll drop them, and sometimes the wind or whatever will just drop, they'll just fall. But
and you're leaving the trees for what purpose? The fallen down trees?
The trees that fall down we will remove. The ones that like this one that is standing, we're going to leave for wildlife, but once they fall we will remove them, just to make it easier for cleanup after a fire, because we have to have everything put out, no smokers, by sunset. So you light the fire for 1 hour and you put out smokers for 3.
And are there any specific wildlife that you're aware of that benefit from the
woodpeckers is what red-headed woodpecker is what we're looking at. A little bit more about girdling trees. The roots are still alive and they're still transporting water and nutrients up to the top of the tree, so it'll leaf out and it'll photosynthesize, but those nutrients cannot get back down to the roots because we've severed the connection. And also sometimes we will girdle the tree because it's in a precarious position where there are some trees around it and it looks like it's just going to get hung up, and we don't want to damage the trees that we're trying to keep, so we will just girdle it and just leave it.
And is there a minimum size tree diameter in which girdling is most effective?
I would say about 10-inch DBH, and below we will just drop it. Above that we can girdle it.
And for those not familiar with DBH, what does that stand for?
Diameter, 10-inch diameter.
So a good question might be, what are we standing in? What kind of forest or woodland is this? And so one way of sort of estimating, of course, is to look up. It's nice to be able to look down like a bird, but we can't do that. So we have to look up from the ground, and you kind of get a sense here, you know, looking at how much green versus white sky you see here, and you just have to guesstimate sort of what it is. But I'm looking at this and thinking it might be roughly 65 to 75% canopy coverage, something like that. I put that into the category of an open forest. Remember, forest goes from 65% canopy cover to 100%, but within that range, we can divide it into either a more open, which of course means more light, or more closed, which means less light. And a lot of that is due to the fact that there's not much of a subcanopy or understory here. And so by subcanopy, of course, we mean trees that are just below the height of the canopy trees. So those are the trees that are sitting at that stage where they're next to occupy the canopy whenever a position comes open. And then below the subcanopy, there's often, again, in a forest, there's more layers of trees at different heights. Again, some of those are young trees, some of those are trees that naturally don't grow very tall, like ironwood, saplings, or even shrubs. Those all, again, diminish the light even more. When we're talking about, again, the amount of light that's important, it's the amount of light that's down here at the herb layer. And because of the clearing that they've done here, there's really not much of any of that understory here. That, too, is what's, again, making the canopy coverage much less. There's another plant over here that I noticed as we're walking around that I thought I'd point out, because it's one that is, again, a good species, I think, kind of in open forest or closed woodlands. And it's this one right here with the leaves that are in whorls of 5. See 5 leaves here, all attached at a common point. So a whorl of 5 leaves. This is purple Joe Pye weed. Eupatorium purpureum was the former name. I believe that's still the current name, though, for this species. Some of the eupatoriums have changed their genus name, but I think this one's still the same.
We're here at what we call the East Prairie, and when Easter Lake was dredged, some of the material was driven via truck, dump truck, to the southern half of this prairie, and we used that for fill. And what has happened is we are getting real erosion from where the trucks have driven. There's I think there's 3 rills here, and as you walk south, there's just a continual line of rills that just come off of the prairie from that.
Okay, so what could be done to repair these areas? Well, there are a couple of options. First off, if they brought a lot of traffic through here, the soils likely are heavily compacted. So I think a combination of tilling and regrading, and you'll get the soils loosened, decompacted. Then you have to think about, well, what are you going to use for vegetation reestablishment? So they're looking at planting prairie. They want prairie in here. They may have to use a nursery crop such as oats. But then also they have slope here, so they'll have to think about how can you break up the slope. And then of course you need some sort of erosion control, otherwise all of your seed is going to wash away. So what they potentially could do in this area is after regrading, tilling the soil, they could reseed and hydromulch, and the city does happen to have hydromulch equipment, so that's like totally awesome. And then come in here and you need some sort of sediment control to break up the slope length, so they're like little check dams to slow the flow down. So then they would use several rows of wattles or filter socks going down this slope. And then I talked about the erosion control. They could hydromulch with seed, or the other option is that they seed and then they use an open weave blanket of some sort. That could be jute or that could be wood coir. It's important when establishing natives that you use the open weave. Otherwise, based on personal experience, if you use the tightly woven blankets, sunlight will not get down to the soil surface for seed generation, and you'll get a delightful mix of weed growth with very little natives. So anyway, so we'll take a look at the area again and look at how we can better heal the landscape with the combination of sediment controls, first off tilling and regrading, and then you're gonna have to have seed, some mulch for erosion control, and then some sort of sediment control to break up the slope length.
The East Prairie was seeded about 8 to 10 years ago. We waited until we had treated it in the fall, probably August, September, and October. We sprayed it, and then we waited till late December when we knew it was going to get right above freezing. So I started seeding in the mornings when it was 28 degrees, and I would go with the tractor and seeder until it got too greasy to seed, and then I would stop for the day. So it took me 2 days to seed this. And what was here before was probably just a pasture remnant, and we've burned it every other year for a while, and we burned it this spring. These woody species up here are black locust, and they love fire, or that fire just angers them. So we've been treating them basil bark. And that's anytime after July through January. We'll go hit the bottom 18 inches with triclopyr, and that seems to do a pretty good job of killing them and not having them resprout.
Ken, are there any other tree species that are a challenge or invasive that are a challenge to manage?
In this prairie, not so much Siberian elm, but in a lot of our other prairies, we have a lot of Siberian elm that's a real challenge.
Well, let's take a look at some of the species out here in the prairie Ken was describing. First of all, I'll just say that it looks really nice. It's looking pretty good after this burn. It probably was, I think, on the historic photos, if I recall, looking back on those historic photos, that this was probably used as a pasture area, of course. Probably got, degraded somewhat, of course, because of that, overgrazing. But it also leads to the possibility that although most of what we're seeing here, again, was planted, certainly all these species, and we'll take a look at some of them in just a bit, were planted, there still is a possibility, since it was a pasture area when they started, that there could be some remnant prairie populations here. And in fact, when I did the natural history survey, I did find a couple of species, a couple of sedges, for example, which I know led me to believe right away that they were remnant, because a lot of reconstructions or plantings, don't use them. Two species here. First one I'll draw attention to is this one right here. This is Carex bicknellii, bicknell sedge, and it's important because of its coefficient of conservatism. I think it's about a 9 or so, again, and that's on a 10-point scale. So high coefficient of conservatism essentially means that this is a species that, according to the committee of botanists and ecologists who gave these coefficients, our experience with it says you only really find this species growing if you're on a really decent prairie. The other sedge that I found, and I found again this morning, is this species here, Carex bushii. And it's important because it's a special concern species, which means it's on the imperiled species list for Iowa. It's a special concern category, which doesn't give it legal protection, but it does serve to alert the botanists at the Iowa DNR that this is a species they need to watch. And so finding it here on this, well, again, degraded prairie at the time, and prairie reconstruction, both, was very important, because as it turns out, again, this, as Ken was describing, when Polk County Conservation dredged Easter Lake, their initial intention was to take tons and tons and tons of that dredge material off the bottom of Easter Lake and spread it out over this northern part of the prairie here, closer to the lake, because it's not so far away. However, when I heard about that and was in a committee that advises the Des Moines Parks about, again, how they manage the parks, I reminded them that this is a site for this special concern species. So because we knew the species was here, that allowed then that plan to change. And of course, and also the importance was this Calyx spignellae too. These both represent native populations that exist here. They were not planted. And to avoid destroying those, as Ken said, they adjusted their plans and took the dredge material further to the south and dumped it in an area where it's mainly just brome grass. But there are a lot of really nice species out here. A couple of the others I have in my hand here, a couple of the mountain mints. You see two real common ones here. You can kind of see a basic difference in them, in that one of them is got more narrow leaves, one's got a little broader leaves. If you look real close at this one right here, it's also got a stem that's completely glabrous. There's no hairs on it at all. This one here has hairs along the corners of the stem. Remember, these are mints, and so they have square stems, and the corners of the stems on this one have some hairs. This one is Virginia mountain mint, Pycnathinum virginianum, and this one is narrowleaf mountain mint, Pycnathinum tenuifolium. This one's also kind of an important one here too, because narrowleaf mountain mint, it's certainly native to this area, but it tends to be a more southern Iowa species, and so its range doesn't go quite as far north as the Virginia mountain mint. And again, having species at the edges of their ranges, to me at least, again, means that that's a population that should be protected. It may have been another remnant one in here too. I'm not sure if it was on the seed list. Some things in flower though. There's right below me here is some spiderwort. And I looked at the sepals on this earlier. The sepals are these green bracts right here that basically form a flower bud. And you can see the sepals on this one that opened up right here. Since they've got a lot of hairs on them, they're very pubescent. That means this is Triscanthia bracteata, the bracted spiderwort. And again, here's the narrowleaf mountain mint. Here's some, this looks like it's going to be sweet coneflower. Here's some rattlesnake master, Laryngium leucifolium. And again, I say this is in pretty nice shape because they don't see very much cool season grass. If this was indeed a cool season pasture at one time, they did a pretty good job of suppressing it. There's a little bit of bluegrass in some places and maybe a sprig or two of brome here and there, but overall, I'm not seeing very much in the way of those non-native cool season grasses. Here's another one that's commonly planted, and it is appropriate species for this area here. This is Penstemon digitalis, the foxglove beard tongue. And then lots of warm season grasses coming up. These clumps here are some warm season grasses. Looks like maybe Indian grass or big blue stem here, one of the two. Oh, and here is some New England aster. And one more, I guess, at least. Here's round-headed bush clover. So it's looking very nice.
Ken, could you talk a little bit more about the prescribed burns in terms of staffing, their education, training, and then how often your schedule associated with that?
Sure, we use all city staff and they are trained in the Wildland Fire S-130-190 course. And we have to go through the burn permit process. So we have a 6-month permit. It usually is October 1st for 6 months or November 1st for 6 months. And we will burn anytime the conditions allow once we have the burn permit. And the big thing with burning in the city is trying to manage the smoke. So we have to get a specific wind direction and not blow the smoke into the neighborhood as much as possible.
Well, one challenge that a land manager might have as they begin to open up what was a forest, or what is a forest, opening it up, like you see here, opening it up more, getting the understory out, getting more light in, is that in some cases, some of the native herbaceous species might sort of over-respond to that. And you can kind of see a fairly good example of that throughout this area. And again, the species we looked at earlier, common black snakeroot. As we walk through here, there's really a large amount of it here. It's really very frequent. It's like every step you're going to see it. And part of the reason, I think, is some of the life history of this plant. Certainly, it produces fruits that have little stick-type structures on them that make the fruit stick to the fur of raccoons and possums and mice, and so that really disperses the fruits, which of course carry the seeds, disperses those seeds far and wide. And I think, again, just the change from a more shaded environment to a more lit environment, this is a species that just responds to that very well. So and it can grow quickly, again, coming from the seed bank perhaps, increases the amount of that we see. So that can prevent a challenge. And I'm not sure what the answer is. It might be that once fire starts getting in here a little bit more and you start getting more of the other species that should be here as well, some of the grasses and sedges, for example, usually they are a little bit more competitive, and so they might help to push some of that common black snakeroot out a little bit. I kind of think of it as, you started with something that had changed over a long period of time, especially with invasive species in here. If there was a layer of honeysuckle and buckthorn, really changed the herbaceous layer. And now when you're trying to go back to something more natural, things can get out of kilter in a sense. Nature's not going to respond directly to, again, what you envision or what you think you might want. So you have to be prepared for that. That's the point here, is that some of these species are going to maybe take over for a brief time and become more dominant than what they should be. But again, we're trying to get something more open, as you see here. And one of the best ways of sort of verifying, sort of proving on the ground that maybe you're going in the right direction or that is the right decision, is if you find some of these large oak species or trees that have been grown in a more open environment, such as this bur oak down here. This individual here is huge. It's probably got a DBH of over 1 meter at least. So it's a pretty old individual. We can see that some of course, the lower branches are dead there on the left, but we can also see that some of the other branches that were lower down are completely gone now. We see those holes and bumps there. Those are places where there was a branch. But it grew up in an environment that was more open. So that's a tree that's clearly over 200 years old. So 200 years ago, when it was growing here and becoming a tree and getting into the canopy, it was able to grow its branches in a very much widespread fashion, spreading its branches out. And oak prefers to grow that way if it can. And we see that aspect, to some extent there in that tree. That tells us, again, that this was a more open environment at the time this tree was growing. A tree like that is often called a wolf tree. I usually make notes of wolf trees when I do plant surveys and take a GPS so I know where they're at. It's called a wolf tree because, like the wolf, it's sort of a lone survivor. We don't usually see very many of these, so not very many of them. They're kind of the lone survivor of, again, when this environment was presumably a savanna or an open woodland.
So the public is welcome to come here and enjoy this area for themselves. We do have some hiking trails through here, and Ewing Park is located right off of Indianola Road. You'll see a barn. You can park at the barn, or across the road at the Lilac Arboretum. There's a larger parking lot there. And come see the rest of the parks in Des Moines.